Good day, my name is Jay. I am a solution engineer / solution architect for NGINX based in Melbourne, Australia. In this session, what we're going to look at is how you can configure your NGINX or NGINX Plus instance to act as an API gateway. What we're going to discuss for the next few minutes is we'll go over the overall understanding of API management, because that is very essential to understand the functionalities of an API gateway. We'll look at the specific functionalities of an API gateway, and then we'll cap it off with demonstrating on how you can configure an NGINX instance to act as an API gateway and enable the specific functionalities you want API gateway to possess. But before we jump in on the more pointy-ended side of the things, let's look at NGINX Plus or NGINX as a whole. Your single instance of NGINX Plus can be configured as all of the boxes you see on the screen. So a single instance can be configured as a web server, as a reverse proxy, as a load balancer, as a web application firewall, and of course, as an API gateway. On top of that, NGINX is super lightweight, performant, resilient, and it can essentially pretty much run anywhere. It can run on cloud provider A, B, C, or D. It can run on bare metal. It can run on Docker containers, and it can also run on Raspberry Pis if you wanted to. Now, back on the topic of the hour, to understand API gateway, it is quintessential to understand the whole overall API management side of things. Now, in my understanding, API gateway is a subset of overall API management requirements. When you talk about API management tool generally has a dashboard, has some form of GUI, you log onto it, you manage your policies, which you apply onto these specific API gateways, which of course act as data plane. You have some form of analytics and monitoring built into it, where you can go out and view the metrics coming out of the gateways on how these APIs are being utilized. You also have an area where developers can go out and have developer documentation and see which APIs have been published. Now, shifting the focus on a specific gateway perspective. Now, when you talk about the data plane and a control plane model, this specific gateway acts as a data plane. The API management tool acts as the control plane. This API gateway, acting as a data plane, goes out and performs tasks like routing, things like rate limiting, authentication, authorization. These are the tasks performed by this individual gateway. Now, when you go out and Google the definition of an API gateway, what you get back is an API gateway is an API management tool that sits between a client and a collection of backend services. Simple enough, but API gateway in a way acts just as a reverse proxy. It accepts all the incoming application programming interface calls, API calls, and aggregates the various services at the backend which are required to fulfill the specific request, and it returns the appropriate result back to the requester. Now let's understand the API request. So when you think about API call is just like HTTP after all, isn't it? Well, yes and no. So let's have a look at a conventional API call. So what you see on the screen is a very standard API call. It's kind of indistinguishable from any web request, superficially at least. But let's look at something a little more exotic. So what you see on the screen here is the same URI, but now in this specific request, what we care about is whether the requester or the client is permitted to change the price of the item, because you see the patch over here. The payload type is JSON. Are we allowed to accept the JSON payload? There is a specific price and currency. Can they go out and change that? Can they go out and manipulate that? What if someone else is not trying to make the same call at the same very time? Also, with calls like these, you need to decide how much of this you want the application to handle versus how much of this logic you want the API gateway to process, and discard the invalid or requests which do not meet specific criteria. So that's a call for you. Now, talking about API gateway and the essential functionalities it brings to the table, from a very, very high level, we're going to focus on these 6 key functionalities, which is of TLS termination, request routing, we'll look at client authentication, we'll look at fine-grained access control, and we will also look at load balancing. So let's cover these 6 functions from an NGINX perspective. So first and foremost, TLS termination. NGINX enables you to terminate your TLS at the gateway. So HTTPS request comes in, you terminate it at the gateway, and the request going there, that point onward could be HTTP, or you can invoke another HTTPS connection as well. SSL certificate and the key can be stored on the disk, or if you've got NGINX Plus, you can store these in your key value store, which is in-memory data store, which comes with NGINX Plus. NGINX also supports TLS 1.3. So what you see on the screen here is the stock standard default protocol, but NGINX also supports TLS 1.3. Also, what you see on the screen are the default SSL ciphers, which are supported with NGINX. You can go out and configure them. More details on these directives and what ciphers and what SSL protocols are supported is available on the module page for http:/SSL module available on nginx.org. Second key functionality of an API gateway is that of request routing. So let's look at request routing. In this example, we have set up a few locations or a few endpoints which we're going to go and hit. The first one is a very exact match. So what we're going to look at is the equal sign. It's an exact match. If the request meets those specific specific wording, it'll go out and be routed to that specific endpoint. The second request uses regular expression. So over here, it goes out and configures, and it takes, you can probably clearly make it out that it's designed to go out and input a specific year, and it will take some parameters after it because we've got that plus towards the end. You can be very, very creative with NGINX and regex. We can probably do a whole video on that, but I'll include a link to a blog which takes you through the specific details on how you can be very, very creative with NGINX and regex. There's also a tool which you can use and work to validate if the regex is going to work on NGINX or not. So in this specific case, all our requests are being routed to the same upstream. But in a real world scenario, if you're using it for more than one APIs or upstream pools, you can have more than one upstream groups. So for example, one endpoint goes to F1-API, another endpoint can go to, say, MotoGP.-API, or another one can go to Cricket-API if you wanted to. Load balancing. So NGINX Gateway can also act as a load balancer at the same time. In this particular case, what we have is we have two specific backends, and NGINX is load balancing against those two backends. And for those of you who've seen my previous video on load balancing side of things, you can make out that in this scenario, the round-robin load balancing method has been applied because we haven't specifically suggested any other method. But what you can see is we've also got sticky cookie enabled. So what I mean by that is in this specific scenario, every time a request is generated and routed to a specific endpoint, NGINX creates a cookie, and the cookie is sent back as a response. And every time the client requests another request, that cookie is always appended. So NGINX routes that request to the same upstream or the same endpoint at the backend. The selection of that is based on a round-robin fashion. Rate limiting. So NGINX uses the limit request zone or limit_rec_zone directive to apply specific rate limiting. It is used in the HTTP context, but outside the server context. You can have more than one rate limit request zones and have multiple rate limit configurations applied to them. So each endpoint where you want to apply a rate limit needs to have a limit_request directive applied to it, referring to which zone configurations you want it to refer to. In our case, we just have one, and we have set a rate limit of 5 requests per minute, and we have enabled that at the endpoint of API/F1/drivers. So with this, if NGINX instance gets more than the specified rate limit requests, the client gets a 429 error, essentially stating that they've exceeded the maximum available limit. Client authentication. So here are the configuration. Here's how you configure authentication with NGINX instance. So in this specific example, we're using JWT-based authorization. JWT is only available with NGINX Plus. You cannot avail this feature on NGINX open source. You can follow a longer tutorial. I'll include a link to it, which actually takes you through the details on how you can configure and go out and enable JWT authentication. I'm not going to go into the specific details on how you configure it, but what I will get you to do is cast your eyes on this specific file over here. So the API_secret.jwk file essentially verifies the incoming JWT tokens for authenticity. And upon validity, the request is proxied to the specified backend over here. So in this case, if the API key is valid, the request is proxied, or else it's rejected and says you're not authorized. Now we can take the client authentication and build upon it, and build upon it to create some form of client authorization. In this configuration, what you see on the screen, we are performing a very, very basic. Now, I emphasize and stress on the word very basic for all the security experts watching this video. Now, the type of authorization I'm doing is based on a specific token or a key included in the JWT token. Excuse me. The JWT token is going to have a certain value contained within it. NGINX is going to introspect the token data, match it to the UID parameter, as you can see from over here. So in the JWT token, which I'm creating, it's got a few parameters. UID is one of those parameters. It's going to try and view for the value of 222. And if the value is a match, the request is proxy passed to the F1 API. And if the request is not a match, 403 is returned for the end user. Now it's time for demonstration. So let's jump on to the VM which I've created. Let's start with looking at what version of NGINX I've got installed. NGINX.3. You can see that I've got the latest version of NGINX Plus with P1 installed on it. Look at the configuration files I have. I've got a dashboard.conf. If I do cat on dashboard.conf, essentially it just goes to show that I've got a simple dashboard which I can view and view what endpoints I have configured. I can go out and make some simple changes from the dashboard as well. However, the file we're going to spend most amount of our time is the API_gateway. So this is the file. And as you can see that I've got two endpoints out here. So this is the API service running locally on my local machine. Local machine listening to port 443. And I've got SSL certificate and a key configured over here. These are the endpoints I've configured. And as from the slide deck earlier, these are the matches which we've created. So this is an exact match over here. This is a prefix match, and we've got a regex match over here. And this is all I have pre-configured. We'll go ahead and configure other configurations as we move along. Close this configuration here, and I'll go sudo docker ps to show you the API which is running on the local box. Now, you know that the API is running on my API gateway already. And to test that, I'm going to use Postman to go out and make a simple call. So I'm going to use Postman to go out and click send. You can see I'm getting a written response. I'm going to try and make the configuration change to drivers first. Hit send, and you can see that response is coming back. We can try that with seasons. And the response is coming back. Try circuits. Getting a response. Right? No. Aha. Do that and do send, and we've got a response. So we're getting a response for all the API endpoints. Now we can also try the regex configuration, which we did was, so we go 2021, which is the year, and we're getting a response for that year. So it's essentially giving you an output of all the races which happened in year 2021. If I put a slash at the end of it and go last, you'd get details about the latest Formula 1 race. So all the petrol heads out there, you'd know exactly when this race was run, who probably won. I have no idea. But the whole idea is you want to try and see some output from the API which was created. Perfect. Let's jump on. Before we jump onto the VM again, let's have a look at the SSL certificate which I configured. So I've got the example.cert and example.key created earlier. And as you can see, it's just got my name here. It's a self-signed certificate just to essentially show you how you'd go out and configure a real certificate with your NGINX instance. Fairly simple. As a very first step, what we did is we did routing. As a very first step, let's just jump in and configure load balancing. So at this stage, we've got this API, and let's just go out and make a few API calls. So I'll just go sudo We'll clean up the data so you'd see that there's 0, 0. We come back to Postman, and what I'm going to do is hit this request a few times. And as you can see, where I want you to cast your eyes is total number of requests is being equally distributed between the two endpoints, so 8001 and 8002, and that is exactly what we want. So at the moment, NGINX's default load balancing method is round robin, and every request which comes in, it is in a round robin fashion, passing it across both servers. So number of requests spread across the two servers should stay pretty even. Now, let's just jump in and configure sticky session. So essentially, we will go out and say that, you know what, every time a request comes in, we want that request routed to the same service, essentially providing much better configuration for the end user. So let's just go ahead and do that. To enable that, I've got a configuration pre-created here just to stop myself from being affected with fat fingers. So added this file over here, and we just simply insert a simple line, sticky cookie, server ID expires in 1 hour. Save this configuration, close this. Reload the configuration. And now let's go out and have a look. And when we go out and make a request, what happens? Hit drivers, make a new request, and you can see that cookies parameter has come up, and you can see a new cookie has been sent. If you look at the headers, you'd see that it's got a set cookie header, and the request is sent out here. But now let's jump back to the dashboard. Let's look at this dashboard. Keep an eye on the total number of requests over here. And I'm going to try and hit send a few times to see how the requests get distributed across those two backends. You see what's happening? So all the requests are being routed to the same upstream or the same backend instance. Now they're not being evenly distributed across the two because we have enabled sticky session. This is very, very beneficial if you want to try and create much better performance for your end users. Now, let's jump in and configure rate limiting for one of the endpoints. So to try and do that, I'm going to implement a super aggressive rate limiting policy. And let's just go ahead and do that. Come out here. And there we go. 1 request per second. And what we need to do is, now that we've defined this globally, we need to define the limit underscore request parameter for the endpoint where you want to enable the rate limit. So I'll just come out here. This. So essentially, the /drivers endpoint is going to have this specific rate limit applied to it. Hit save, close that. NGINX does as reload, come back out here and ensure it's drivers. You got the body and hit send a few times, and there we go. You got 429, too many requests, and that is what we expect. However, at this stage, if I was to jump from drivers to seasons, for example, and hit enter a few times, you can see that there's no rate limit which is applied to it because the rate limit was only applied to the driver's endpoint. So perfect. That is exactly working as we anticipated to. Now, as a next step, let's just go out and configure authentication. We'll edit the NGINX configuration, and let's apply configuration on the circuits endpoint. For that, what I'm going to do is enable this. So please note that I've got the API underscore secret.jwk enabled on the same box in the NGINX directory. And we need to proxy pass it to that endpoint when it is successful. Perfect. We'll save this, we'll close this, we'll reload our NGINX configuration. However, before I do that, I just want to show you the API underscore secret.jwk. And this is just essentially a cipher which I've created using jot.io. You can just go to jwt.io, follow the steps to go out and create a specific JWT token and an API key. Ideally, what you want to do is you want to have a third-party authentication and authorization system where you're authenticating using Okta or Ping Identity or Microsoft or whatever it may be. That is a much safer and better approach to take. So NGINX still routes that request to your authentication server and gets the token back from your authentication server. And based on what it gets back, it routes the request to the valid endpoint at the backend. Perfect. Now that we've applied this at the circuits endpoint, let's just go out and see. We've got no authorization over here. Go to circuits and hit send and see what we get back. And hey, there you go, 401 authorization required. And this is exactly what we anticipate because we've gone out and enabled authentication for that specific endpoint. If you don't have a valid key, you would not have access to that specific endpoint. In my case, I happen to have the valid key with me. So I'm just going to apply a valid key to the bearer token and hit send again and see, there we go, we have a response back. We look into the headers. Of course, the cookie is still there. And we've got a response back. So I can hit enter a few times. There's no rate limiting. We've only applied authentication on it. Now, if you had to try and extend this authentication a little bit and say, hey, now we wanted to try and apply some kind of fine-grained authentication on it. Now, what I'm about to do is a very, very, very simple way of authorizing a specific user or a specific request to a specific backend or upstream server. But it gives you an idea. The idea of doing this exercise is to try and make you understand on how authorization actually works. So let me go in and apply this simple example, what we're talking about. Right? Did I do there? Yep. This is what we want. So once again, we'll come back to the circuit API. We'll remove that, leave that on. And what I've got here is a simple if statement. This is, okay, leave it as it's no problems. We're adding a header based on the XJWT claim UID, and all it's doing is grabbing the value which is contained within the JWT token as a variable, and it's going to insert that into the header if the claim is successful. If the claim is not successful, it's going to go out and type a message that invalid user and no redirect was applied. It'll return a 200. You don't want it to return 200. I've got it there. I want it to return 403 and say not authorized to access. Let's try and change that a bit. Rather than not authorized to access, we can say forbidden. That makes no sense. There we go. Forbidden. You don't have access to this resource. Perfect. We'll save this file here. We'll show that it got proxy pass, return 403, JWT on, endpoint circuits. Save this here. NGINX reload. Perfect. That should work. So we jump back to our Postman. The endpoint stays the same. Our JWT token still stays the same over here. And let's go out and hit enter and see what we get. And it says forbidden. You don't have access to this specific resource, which is ideal. That's what we expect. So if you look at the headers, it says the JWT claim UID is 111, which is correct because the JWT token, which I created, has the UID of 111, which I created earlier, and the status is invalid user. Now, I've also got another JWT token, which has the UID of 222, which the if statement, which we created in the API config expects. So let's just go in and apply that and see what we get. So what you want to look at is the header, which NGINX inserts. Hit enter, and there we go. If you look at the body, you've got a response here. We come back to the headers, and you'd see that JWT claim UID at this moment is 222, and it's redirected to the backend API. So this is exactly what we want to see. So essentially, we've gone out and enabled authentication and very kind of very simple or a basic authorization from your NGINX API gateway itself. So from a demonstration perspective, this is all. I'm going to include all the links which I used. I'll also include the JWT tokens which I used for this demo in the GitHub link, which I'd have in the comments down below. But with that, thank you very much for watching and see you again in the next video.